Hello friends, welcome back to my channel. So my name is Pramod Thorat and this is another module for CompTIA A Plus certification series. So before we get started, don't forget to subscribe this channel to see more video like this. So let's go to the module 3, CPUs and cooling. So this is the model 3, central processing units and cooling. So objective for this model is PC hardware is differentiate among various central processing unit types and features and select the appropriate cooling method. So what is the central processing unit? So in the microprocessor history, in 1945, John von Neumann was the first to suggest storing a sequence of instructions, a program in the same memory as the data. And first draft of a report on the IDVAC organized the computer system into 4 main parts. First one is the central arithmetic unit, second one is the central control unit, C is a memory, and D is input output devices. So today, more than half a century later, nearly all processors have a von Neumann architecture. So in microprocessor history, also known as the CPU or central processing unit, complete computation engine fabricated on a single chip. So Intel 4004 introduced in 1971. First microprocessor was not very powerful but could only add and subtract 4 bits at a time. Powered one of the first portable electronic calculators. And the second processor is Intel 8080 introduced in 1974. First microprocessor to make it into a home computer, complete 8-bit computer on the chip. Next processor is Intel 8088 introduced in 1979, incorporated into the IBM PC, which first appeared around 1981. The PC market moved from the 8088 to 80286, 80386, 80486, Pentium, Pentium 2, Pentium 3, Pentium 4, and the dual core 6, 8 cores. So all of these microprocessors are improvements on the basic design of the 808 processor. And let's check the attributes used to rate CPU. So CPU speed measured in hertz, megahertz or gigahertz. So efficiency of programming code, number of transistors, number of registers, data path, maximum number of memory addresses, amount of memory included with the CPU, multiprocessing ability, spatial functionality. So let's check the next slides. This slide we can see the CPU architecture. So input output units manages data and instructions entering and leaving the CPU. Arithmetic logic units, ALUs, so does all comparisons and calculations. Control units, so manages all activities inside the CPU itself. And the memory units, everything the CPU access must first to be in a memory, to be stored in a memory. So let's check the next slides. So how the CPU works. So this is the basic design for the CPU, central processing units. Bottom line is the input output unit, control unit, ALU, internal memory cache, registers, backside bus, Pentium CPU, or internal data bus is a 32-bit wines. So beginning with the Pentium, CPUs had 2 arithmetic logic units and the processes 2 instructions at once. So let's go to the next slide. In this side you can see the CPU packages. So first one is the SCCC, single edge contact cartridge, SCP, single edge processor, PPGA, plastic pin grid array, PGA, pin grid array, LGA, LAN grid array, SPGA, staggered pin grid array, MPGA, micro pin grid array. So let's check the pin grid array and the LAN grid array. So LAN grid array is the most common types of central processing units inserted into a 0 insertion force chip socket mounted on the motherboard, as you can see on the screen. The processor referred to as a chip. So let's move to the next slide. In this slide we can see the CPU slots and the socket. So physical connection used to connect the CPU to the motherboard. Socket X big is a numerical, is a descriptive term for the way certain processors plug into a motherboard. Terminology like socket 7, socket 370, LGA 775 or LGA 1155. Slot type processor had a very brief lifespan. The slots 1 was proprietary to the Intel Pentium 2, slot A was proprietary to the AMD Athlon. Current socket types are LGA 1156, this is Celeron, Pentium, Core i3, i5 or Core i7. LGA 1155 replaces the LGA 1156, LGA 2011 replaces LGA 1366 and LGA 1567, LGA 1150 replaces the LGA 1155, socket FM1, socket M3+, socket FM2. So let's check this slide what is the cache memory in a computer system. So memory is relocated into a special section of high-speed SRAM inside the processor. Uses a small amount of expansion memory to speed up processing instead of a large amount of slower, less expensive memory. So increases the memory access speed of computer. Microprocessor could access these locations without requiring at any wait times. So in cache memory there are three types: L1 cache, L2 cache and L3 cache. So L1 cache is the fastest memory. Smallest size is 4 kilobytes to 62 kilobytes, 16 kilobytes in size, built into the CPU. Stores frequently used information that the CPU speed. L2 cache memory, next fastest memory, a little larger, stores frequently used information that cannot be held in L1 cache. L3 cache stores frequently use information that cannot be held in L1 or L2 cache. Largest type of cache memory can be built directly on peripherals. So let's move on next slide. So what is the pipelining in the computer system? So instruction execution overlaps. Even though it might take 8 clock cycles to execute each instructions, there can be 8 simultaneous instructions in various stages of executions. Looks like one instruction completes every clock cycles. Many modern processors have multiple instruction decoders, each with its own pipelines, so allow for multiple instruction streams, which means that more than one instructions can complete during each clock cycle. The technique can be quite complex to implement, takes lots of transistors. So let's check what is the multiprocessing in the computer system. So running a system with more than one processor, in theory you can doubt performance by using two processors. Operating system must support it. Operating system divides tasks between processor in A is asymptotic or B is symmetric. So let's move on to the next slide. So first one is the symmetric. So designated some processor to perform system tasks only and others to run applications only. A rigid design that may result in lost performance. A symmetric allow other system or user tasks to run on any processor, leads to better performance used by most multiprocessing motherboards. So let's move on to the next slide. So what is the hyperthreading in the computer system? So enhanced CPU performance, schedules multiple processes simultaneously among multiple logical processors, makes every logical processor cores appears as a physical cores. And what is the CISC, complex instruction set computers? The traditional architecture of a computer allows multiple instructions to be written in a one line of code. High efficiency programming, variance in length, requires complex circuitry to decode them. So let's move to the next slide. In this slide, we can check the RISC, reduced instruction set computers. So execution instruction very fast, one cycle or less, requires fewer transistors, cheaper to design and produce, keep instruction size constant, ban the indirect addressing mode, retains only those instructions that can be overlapped, used by Apple computers. So let's move to the next slide. So we can see in these slides 64-bit processors. So 60-bit processor introduced in 1982, now becoming mainstream, produced by Intel and AMD. 64-bit ALUs, 64-bit registers, 64-bit buses. Microsoft first 64-bit processors were known as Itanium processors. So let's move to the next processor. So let's move to the next slide. So 64-bit processors and memory. So 32-bit chips have maximum of 4 GB of RAM, limit size of programs and data. 64-bit RAM access is essential infinite. So 2 raised to 64 equals about a quadrillion gigabytes or 102 terabytes or 1 petabytes. So increased system performance, creates high-speed data buses on the motherboard, faster input-output speeds. So let's check the next processor, Neon. So Intel server CPU x86 and 64X versions have more cache than their desktop counterparts, multiprocessing capabilities, found in the top 10 of the fastest supercomputers in the world. So let's check the next processor. This is the Sun Spark processor, and this is the basic design for the Sun Spark processor. So 64-bit processor built to run Sun Unix servers, eliminated the North bridge by incorporating the memory and PCI controllers into the CPU. So let's move to the next processor. This is a multi-core processors. So incorporate more than one CPU core onto a single chip, capable of processing multiple instructions concurrently. Available processors: A is a single core CPU, dual core CPU, quad core CPU, 6 core CPU, 8 core CPU. A motherboard may have multiple sockets. So let's move to the next slides. So what is the thermal compound? So keep your CPU from overheating. Better CPU performance and stability, creates a reliable transfer of heat and from processor to heat sink, made of micron-sized silver and ceramic particles. as you can see on the pictures on the screen. What is the CPU cooling? So all electronic components generate heat causing slower performance, component damage. So component performs better when kept cool. So that's why CPU cooling is most important part of the computer. So let's move to the next slide. Microprocessor cooling system. So as you can see on the screen, first one is the passive cooling, second one is the active cooling, and third one is a video card with active cooling. So heat sinks, passive cooling is used by older CPUs to pull heat away from the CPU, mounts on top of the CPU. Cooling fans, active cooling keep temperature lower by drawing air across the heat sink, powered by an electrical connections. So let's move to the next slide. So water cooling. So what is the water cooling in the computer system? So use the extremely fast CPUs and GPUs. A metal plate is placed over the processor and water is pumped over the top to collect the heat and the CPU creates. Water is pumped to a radiator to be cooled by the air and then recirculated, as you can see on the picture. So provides a very quiet option when noise is a factor. So we can move to the summary for this module. So in this module, we discuss processor history, attributes and makeups, processor packages and motherboard slots and sockets, cache memory, pipelining, multiprocessing and hyperthreading, types of processors and types of cooling. So you have completed this module. So study hard, good luck and thanks for watching. I will upload next module shortly. So please don't forget to subscribe the channel to see more video like this. Thank you.